Look up at the night sky. Thousands of stars shimmer back at you, each one a distant sun in its own right. Now consider this. Each of those stars could have planets orbiting it just like our sun, forming their own unique solar systems. Some of those planets might be similar in size and temperature to Earth, potentially harboring conditions suitable for life. Could there be life on these distant worlds? Could there be civilizations looking up at their own night skies, wondering the same thing? It's a question that has captivated humanity for centuries, from ancient star maps to modern telescopes. We are driven by curiosity, a desire to explore the unknown, to push the boundaries of our understanding. The vastness of space, filled with billions upon billions of stars and planets, begs us to ask, are we alone in this immense universe? While we haven't yet discovered definitive proof of extraterrestrial life, the universe is full of possibilities, each more intriguing than the last. Just imagine the diversity of life that could exist out there, in forms and environments we can scarcely conceive. What would it look like? How would it function? Would it be similar to life on Earth, or something entirely different? What would it mean for humanity to encounter another intelligent species? How would it change our understanding of life and our place in the universe? The search for life beyond Earth isn't just about satisfying our curiosity. It's a quest to answer fundamental questions about existence. It's about understanding our place in the grand scheme of the cosmos, seeing Earth as one small part of a much larger picture. It's about expanding our definition of life itself and realizing that the universe may be teeming with life in forms we have yet to imagine. When we think about life on other planets, we often picture something resembling the familiar. Lush forests, vast oceans, creatures that breathe oxygen. These are the images that come to mind, shaped by our own experiences on Earth. But what if life finds a way even in the most extreme environments? What if it thrives where we least expect it? Here on Earth, we have extremophiles, organisms thriving in conditions that would be deadly to most life. These tiny survivors challenge our understanding of life's limits. They exist in scorching hydrothermal vents where temperatures soar and toxic chemicals abound, in the frigid depths of the ocean where sunlight never reaches, even within solid rock, miles beneath the Earth's surface. These resilient life forms show us that life can adapt to a surprising range of conditions. They redefine what we consider habitable. The essential ingredients for life as we know it are liquid water, a source of energy, and a collection of specific chemical elements. These are the building blocks of life as we understand it. These elements, like carbon, hydrogen, oxygen, and nitrogen, are the building blocks of life's complex molecules. They form the very essence of our biological makeup. However, who's to say that life elsewhere is bound by the same rules? The universe is vast and varied. What if silicon replaces carbon as the backbone of life? Silicon-based life forms could exist in environments we can't even imagine. Or ammonia takes the place of water. This could open up entirely new possibilities for life in the cosmos. The possibilities are as vast as the universe itself. As we continue to explore, we may find that life is more diverse and adaptable than we ever dreamed. Imagine a planet, a gas giant, larger than Jupiter, with swirling storms of colourful clouds. Now, picture a moon orbiting this giant, a world with a thick atmosphere and a gravitational pull much weaker than Earth's. This is where we might find life unlike anything we've ever seen. On this hypothetical moon, gravity's gentle pull could allow for the evolution of massive, buoyant organisms. Picture floating forests, vast networks of interconnected plants suspended in the dense atmosphere. These aerial ecosystems could be home to a dazzling array of creatures, sky serpents with bodies thinner than air, bioluminescent birds that navigate through the perpetual twilight, and perhaps even intelligent beings who have never known the feel of solid ground. Life on a gas giant moon would be a testament to the power of adaptation. The challenges of this environment, from the lack of a solid surface to the constant winds, would have shaped life in ways we can only begin to imagine. Super-Earths, planets larger and heavier than our own, are relatively common in the vast universe. But what would life be like on a planet with significantly stronger gravity? On a super-Earth, life would need to be incredibly robust and adaptable. Imagine creatures with dense bone structures and powerful muscles, built to withstand the crushing pressure of gravity. The flora might consist of short, sturdy trees with incredibly deep root systems, anchoring them against the relentless pull. However, high gravity could also lead to the evolution of miniature creatures. With less need to overcome gravity's pull, smaller organisms could thrive. Imagine insects the size of birds, or tiny mammals with lightning-fast reflexes, navigating a world where every movement requires significant effort. Life on a super-Earth would be a delicate balance between strength and efficiency. Could intelligence even arise in such a challenging environment? It's a fascinating question with no easy answers. Under a blazing sun, survival in the desert world is no easy feat. Not all planets teeming with life are lush paradises. Some might be harsh and unforgiving, like a planet locked in a tight orbit around its star, a world dominated by scorching deserts and unrelenting heat. Life on a desert planet would be an exercise in resilience. Imagine creatures with thick armored skin to prevent water loss, and the ability to burrow underground to escape the sun's relentless rays. Nocturnal predators might emerge under the cool light of the stars, hunting prey that has adapted to conserve every precious drop of water. Even on a world seemingly devoid of life, we might find extremophiles clinging to survival. These hardy organisms could exist in underground aquifers, utilizing geothermal energy and surviving on minimal resources. Perhaps, in this desolate landscape, they hold the key to understanding how life can persist even in the most extreme conditions. Echoes of intelligence, will we recognize it? The search for extraterrestrial life often centers around the question of intelligence. But how would we recognize an alien intelligence, especially if it's vastly different from our own? We tend to define intelligence based on human capabilities, tool use, language, and problem solving. But these might be just one expression of intelligence, shaped by our unique evolutionary path. What if intelligence on other planets manifests in forms we can't even comprehend? Perhaps there are alien species that communicate through bioluminescence or navigate their world using echolocation. Maybe their technology is so advanced, so seamlessly integrated into their environment that we wouldn't even recognize it as such. The search for extraterrestrial intelligence requires us to broaden our perspective. We need to be open to the possibility that intelligence can arise in countless forms, each a testament to the creativity and adaptability of life itself. A universe of challenges. Could we ever adapt to such an unknown and vast frontier? The prospect of discovering life on other planets is exhilarating, sparking our imagination and curiosity. But what if we wanted to go further, beyond mere discovery? What if we dreamed of one day living on these alien worlds, making them our new homes? The reality is that surviving on most exoplanets would be incredibly challenging for humans, given their harsh environments. We are adapted to the specific conditions of Earth, its gravity, its atmosphere, its temperature range, and its unique ecosystem. Even slight deviations from these can be hazardous to our health, affecting our bodies in unpredictable ways. On a planet with higher gravity, our bones and muscles would be under constant strain, leading to potential long-term health issues. A thinner atmosphere would make it difficult to breathe, requiring advanced life support systems. And extreme temperatures could be deadly, necessitating specialized thermal suits and habitats. Even the microbial life on these planets could pose a threat, as our immune systems would be unprepared for these foreign organisms. This could lead to new diseases and health challenges that we have never encountered before. Colonizing other planets would require significant technological advancements, including new medical technologies and life support systems, and a deep understanding of both human biology to ensure our bodies can cope with the new conditions and the specific challenges of the target environment to develop effective solutions. It would be a monumental undertaking, involving large-scale construction and resource management, one that would push the boundaries of human ingenuity and resilience, testing our limits and expanding our horizons. The final frontier, a universe of possibilities. The search for life beyond Earth is a journey of discovery. It's about pushing the boundaries of our knowledge, challenging our assumptions, and embracing the unknown. While we haven't yet found definitive proof of extraterrestrial life, the vastness of the universe, with its billions upon billions of stars and planets, makes the possibility incredibly likely. Each new discovery, every planet we observe, brings us one step closer to answering the fundamental question: are we alone? But more than that, it reminds us of the incredible diversity and resilience of life itself. So, the next time you gaze up at the night sky, remember this. Somewhere out there on a distant world bathed in the light of a foreign star, life might be flourishing in ways we can only dream of. The universe is full of possibilities, and it's up to us to explore them.